Looking at example 3 now. Here it's talking about Sean. That's my older brother. That's how he spells his name as well. Sean estimated that the attendance at a college lacrosse game was 3,000. The actual attendance was 3,296. So what is the percent error in Sean's estimate? And in this case, who cares about the error? It's kind of great, but if they're looking at safety measures, if they're looking at food consumption, whatever things they need to evaluate, they want to try to estimate that correctly so that they're not wasting money or wasting sales on the back end. So anyways, what is the percent of error Sean's estimate? Round to the nearest whole percent. So we're going to use absolute value to find the positive difference between the estimate and the actual attendance. So if the attendance was 2,700, like we did in the previous problem, we're not looking at that as a minus 300. We're just going to take that value and calculate its percent. Okay, so here, I think you all see that the difference is 296. So again, we use part, percent, whole. A whole amount was 3,000. We had a percent of error. Let's call it X. And then our part was 96 or 296. So we're going to divide by 3,000 on both sides to balance out our equation and to get X by itself. Again, this creates a 1. It doesn't just cancel each other out. It's a way of us to make this equal 1 and to balance it to the other side. So we have X on this side equals 296 divided by 3,000. Okay, so we can set up that long division, which I'm okay. We're not emphasizing long division right now. Sometimes it's really just relative to the topic. But at the same time, you guys practicing your long division every now and again is good in the sense that you may have test questions, state exams, stuff like that, where they're like, you can't use a calculator. So you want to get your practice in periodically throughout the year. So this does end up equaling 0.098 and then 6 repeated. Just the 6 repeated, not the 8 and not the 9 or the 8. So it would just be, if you really need to see that, it would be 9, 8, 6, 6, 6, 6, and so on, right? So that equals our X. And they asked us earlier, round this to the nearest whole percent. So when we move our decimal, we're going to get 9.86 repeated as our true percent. So we're going to round that up to a 10% error. So again, nobody's disappointed. We got more people in attendance. There may be some reasons that's good, that's bad, but it definitely takes some planning to make sure that it becomes the best outcome for those involved in that game and that event.